This video is sponsored by Picastro. It's like Instagram for space nerds. Well, good evening and welcome to Space Oddities. Thank you for joining us on this Tuesday evening. We hope everybody out there in YouTube land is well and that you've all had a fantastic week. How's the weather been in the UK, chaps, this week?
Mixed, very mixed.
Yeah, mixed.
Oh, right.
Windy.
Oh, right. No, we've had temperatures up sort of 36, 38 again. But today it went down to 24, would you believe? And we had some rain this afternoon, and we were in absolute heaven. But it's very humid, so it's still a bit of a struggle. Anyway, enough of all that old chutney. Viewers, thank you so much for joining us. If you're new to Space Oddities, you're especially welcome here tonight, and we hope you'll stick around. Got the usual suspects here tonight with Daz and Michael and Roger and what's his name over there? Lou, that's the one.
We're far away, so I get it.
Yeah. Hope you're well, gentlemen, and raring to go for another spiffing edition of Space Oddities. And we certainly are. We've got a lot to get through today. So what are we going to tell you about today? Well, today we are going to be telling you about the phantom planet of Alpha Centauri. If you don't know what's going on there with the phantom planet, Lou is going to explain about that planet and other planets in the whole Centauri system. I'm going to be telling you about a project called the 30-Metre Telescope, which is carrying on with our series of looking at observatories that are going to be coming online over the next several years. We're looking at the 30-Metre Telescope tonight, which has a really interesting past, and it's the most controversial telescope probably ever proposed to be built. So we'll tell you all about that. We've got Constellation of the Week from Michael. We've got the usual night sky guide and viewers gallery from Roger. And we've got Einstein of the Week making its return. It was a very quiet week last week. Didn't see anything that was remotely suitable for Einstein of the Week. But it's been a bumper week this week for Einstein of the Week. All of the crazies seem to have come out of the woodwork this week. So we've got a bit of a bumper edition of Einstein of the Week towards the end of the program for you this evening. We'll get straight on with things. And I think what we're going to do is we are going to go straight over to the news. Actually, before we do that, let's just go through the usual housekeeping stuff. If you would like to support Space Oddities, which obviously we hope you do, then you can, of course, buy us a coffee at buyusacoffee.com. If you scan the QR code or click the link that's just appeared in the chat, you can buy us a coffee, keep us going in caffeine, and all monies obviously go towards keeping the channel running, which is what we want and we hope is what you want as well. So keep us going in caffeine, buy us a coffee. You can also, of course, click the super chat icon underneath the chat window, the one with the $sign on it, to directly make a donation to Space Oddities, again, to keep the channel going. And we don't want to just keep going. We want to expand and do new things in the future. But of course, we need money for a lot of that. So, you know, every bit of money you can spare goes towards helping the channel maintain itself, grow and expand. You can, of course, visit the Space Oddities shop where you can buy yourself some lovely Space Oddities merchandise in the form of t-shirts and hoodies. Don't forget the autumn's coming up, temperatures are going to drop and you'll need a hoodie to go out. And what better way to impress people than with your Space Oddities hoodie and have hundreds of people asking you in the pub, what's that all about? So we hope that you'll do that and spread the word, as we hope you'll always spread the words to your family, friends, and anybody really about Space Oddities. And, you know, we're very grateful for your support. You can also join our Patreon. We do have a Patreon. And if you join Patreon for a very reasonable fee every month, you get lots of goodies. You get all the presentations we give you on Tuesdays. You also get other odds and ends. And if you join, then as a present for joining, we will send you completely free of charge 2 lovely astrophotography prints taken by a couple of the people of Space Oddities They are 10 by 8, beautiful quality prints. And you can get those for absolutely nothing by just signing up to Patreon. It doesn't cost much every month, just a few pounds, but it really does make a difference to us in planning the financial future of the channel. There we are, Sandra. Thank you so much. Yes, I think, yes, buying another hoodie for the winter. I'm sure you're going to need a much smaller size as well this winter, aren't you? As we all do, because we're all on salads and stuff during the summer. And I'll certainly be downsizing. So there we are. That's about it. So these are the various ways you can help Space Oddities survive and indeed develop and grow. All right, then, having said that, we're going to go over to the news now. Oh, by the way, I didn't give you the address. The address of our Patreon is quite easy, patreon.com//Space Oddities. So let's get right on with the news. I've got a few lovely stories for you this week about in the news. So let's have a look and see what's going on. Firstly, some very good news. The Hermann Science Centre has been saved. I don't know about you, team. Did you see this in the press?
Yes, we saw that. Yeah, good.
Yeah.
News. Good news.
Excellent.
It's great news. For those of you who don't know, Hermann is on the Science Centre is on the site of Hermann Castle, which used to be the Royal Greenwich Observatory before it was moved to Cambridge. And it's been under threat for the last couple of years. It's got some grade 2 listed telescopes, as you can see in the image. And it's a fantastic science centre for the promotion of astronomy. Just let me give you the history of this. So first of all, it relocated from London to Hermann in the 1950s. It's got grade 2 asterisk listed telescopes and domes, and it's been the observatory science centre since 1995. But Queen's University in Canada acquired the whole estate, including that fantastic castle that we all know and love, in 1993. I don't know how on earth the university in Canada acquired the site. Yeah. Do you know, Michael, how on earth they managed to acquire the site? Michael?
I'm going to click. Sorry?
No. It seemed weird to me at the time that the university.
Yeah, I don't really know how they got involved in the first place now.
No, it's really weird. Anyway, but they leased it to a company called Science Projects Limited, a charitable operator, and they did develop it into a fantastic leading educational and visitor attraction. But the lease expires at the end of 2026, and for 2 years, Queen's University, who, as I said, own the site now, they've been saying absolutely nothing about whether the lease for Science Projects Limited was going to be extended, which has made a lot of people very, very, very scared that the whole land was going to be sold off for housing or whatever. So there's been a bit of a public backlash. I'll say that again. You know what a backlash is. I'm talking Polish.
Yeah.
A public backlash and campaign was started. This is what social media is absolutely brilliant for, of course. And the petition online got more than 12,000 signatures. Doesn't actually sound a lot in the big scheme of things, but 12,000 is 12,000. But there were big campaigns to get Queen's to at least, say something about whether they were going to extend the lease. And for 2 years, they've just sat back and said virtually nothing.
I signed it.
Yeah, me too. And I know a few people that did. Mm. But the fact that they were being absolutely silent about the future of the site, did not augur well. But it was announced this week that they have extended the lease for another 10 years to Science Projects Limited. So the whole science centre on this historic site can continue. If you've never been to Hermann, viewers, it is the most beautiful place, isn't it, Michael? Well, Daz, have you been to Hermann?
No, I'm afraid not, because they hold an annual sort of like event down there every year. But I've never been able to get down there.
If you can, you should, because it's just wonderful. Roger, you've been, I'm sure.
No, I've not.
You haven't?
Yes, am I the only one?
I'm the only
I don't
one.
get out much.
Oh, no, of course not.
I'm the only one with an excuse. So.
Yeah, that's a damn good excuse, Lou.
I was there in the days of Heather Cooper and Nigel Henbest.
Yeah, me too. They used to have an annual cricket match between amateur and professional astronomers.
All right.
and I went to that one year. And to be honest, I'm not interested in cricket. I just went for the beer.
Yeah.
But I was sitting there getting a bit bored because it did drag on a bit, and I don't understand the rule of cricket anyway, so I didn't know what the hell was happening. The amateurs won, as they had done for the previous 5 years, apparently, which was good. But I was just sitting there and then I heard this roaring coming from behind the trees and I looked up to see a hot air balloon lifting up above the trees, and it was a hot air balloon meet on the same day, and suddenly all these dozens of hot air balloons lifted into the air. It's absolutely fantastic. I've got some lovely shots of the hot air balloons over the castle. But anyway, so I'm rambling. So so good news. The Hertzmann Science Centre is saved for at least another 10 years. So that's good news. All right, what else have we got? The 30-metre telescope. Now, I'll be going into this in detail in a little while. But the thing is that Spain has offered 400 million euros to revive the 30-metre telescope project.
Wow.
Yeah. And you're not going to be I'm really proud of living in Spain now, because Trump predictably wants to withdraw funding from it. But I'll give you the whole history of this.
Headway anyhow. I mean,
yeah, I'll talk about that a bit later. But Spain has volunteered to bridge the funding gap, but there's a condition attached. So we'll have a look at that a bit later. I've got some bad news about TRAPPIST 1D. Now, I don't know whether you remember, viewers, because we have talked about this a few times in the past, but there's a planetary system about 40 light years away, which is called TRAPPIST. And it's got multiple planets that are around the size of the Earth, 4 of which are in the habitable zone. That is where liquid water could exist, in the Goldilocks zone, if you like. Let's have a look at the system then. So this is 40 light years away in the constellation of Aquarius. You've got 7 planets labeled B to H. They're all very close to their sun, and we'll see how close in a moment. But the one that we're most interested in is D. Now, what happened was the James Webb Space Telescope imaged this whole system about 2 years ago, not long after it came online, actually. But it was proprietary data. And what this means is that a lot of data with the James Webb is not released to the public immediately, because the people who ran the observation programs want the opportunity to look at the data and analyze it and write scientific papers about it before anybody else has a chance, because, you know, it's their baby, basically. So this has only recently been released to the public. We were really hopeful that planet D, the 3rd one out from the sun, was very much like Earth, in as much as it had liquid water on its surface, we thought, and an Earth-like atmosphere. So the results of the James Webb investigation are, very sadly, that TRAPPIST-1D does not have an atmosphere, and therefore it won't be able to hold on to liquid water on its surface. So this is a real shame. Here's a table I put together of the whole system. And we've got the planet, the orbital period, the distance from its sun, the radius compared to Earth, whether it's in the habitable zone or not, its atmosphere, if we know about it, and any notes. And you can see TRAPPIST-1D, the one I've highlighted. It takes 4 Earth days to go around its star, so it is very close. The distance is only 0.02 of 1 astronomical unit being the distance from the Earth to the sun. Now, you might say, well, that's far too close to the star. The planet's going to be ultra hot. Well, the star is a small red dwarf star, so it's very cool and doesn't output a lot of energy. So these planets could actually support life if they had the right conditions that close to the star, because they're not receiving nearly as much radiation compared to planets nearer the sun in our own solar system. And although TRAPPIST-1D is on the inner edge of the habitable zone, the JWST has determined that it doesn't have an atmosphere, and its temperature is really just on the edge of whether it would be too hot or too cold to support life. So unfortunately, we're still not looking at any hopeful information about the TRAPPIST system, although there is data still to be released by the James Webb about some of the other planets. But the other ones I think we're waiting for are still in the habitable zone, but they're not thought. Well, scientists aren't as optimistic about the other planets as they were about 1D, because it seemed to be in the ideal position, the right size, and capable of having liquid water. But it now looks as if it hasn't. So that's really bad news. But the search goes on, of course, for Earth-like planets in our galaxy that do have the right conditions to have liquid water on their surface. Why is that important? Because as far as we know, for life to exist, it needs water, or at least something acting as a solvent, which is what water does for cells. But the hunt goes on, basically. We go back to Comet 3I Atlas. Now, we talked about this the last few weeks, of course, because everybody's talking about this. And there's been some rather interesting information discovered about this comet, which sets it aside from other comets. It's releasing a hell of a lot of water. It's actually not water, it's hydroxyl with the chemical symbol OH. It's close to water. It's used as what's called an analog for water. It's virtually water, just about. But this comet is releasing a lot of it for its size. And these are ultraviolet observations with the Swift telescope. And this water emission was found, and it's in the form of water vapor, when the comet was more than 3 times the distance from the sun as the Earth, at more than 3 AU. We don't normally see water activity on comets that far out from the sun. But the rate of it is amazing. It's producing around 40 kilograms of water per second. This means that water is being emitted, if you like, from an area about 19 square kilometers. So what this means is that over 20% of the whole comet is releasing water in the form of water vapor, which when it gets closer to the sun will form a long streaming tail behind it. And this is far higher than is typical for comets. So this could mean that we're looking at a comet that is very different to the comets we normally see in the solar system. Don't forget, this is an interstellar comet. It comes from outside our solar system. It's been traveling around the galaxy for we don't know how long, but it's certainly very, very old. The reason we know it's very, very old is because as it moves around the galaxy, it gets accelerated by gravitational interactions, and it's moving very, very fast indeed, which logic dictates must mean it's very old because it's had a lot of time to pick up that excessive momentum. This extended source of water, what it means is it's got large icy grains in the coma, and this suggests that the water, a lot of the water, a significant share of it, in fact, comes not actually from the nucleus, but from particles released into the cloud around the comet, which turn directly from a solid, if you like, icy grains to a gas, to water vapor, which is known as sublimating. And, this is a really, really odd comet. But viewers, don't believe what you see on social media and in the press. This is a comet. It's not an alien spaceship. Things are still getting out of hand as regards that type of reporting. This is a comet. It's come from outside our solar system. Instead of there being lots of articles talking about the features of the comet, there are lots of articles saying it's an alien spaceship come to destroy us. It's just a sad comment on the state of things, in my opinion, but there we are. Okay, and as I said, few comets show confirmed water emission beyond 3 astronomical units. And so this is, we're not quite sure of the reasons for this, but as it gets closer, hopefully we'll get a better look at it and get some clues as to exactly why it behaves in this strange way. We move on now to the Impossible Galaxy. The Impossible Galaxy has the rather catchy name of Jade's GSZ1 140. It is this red blob pointed at by the arrow. And why do we say that this is an impossible galaxy? Well, because according to our current models of galaxy formation, this really, really shouldn't exist. So let's have a look at the details. It's the most distant galaxy yet observed. It's at a redshift of 14.3, meaning we see it as it was only about 290 to 300 million years after the Big Bang. So that you're looking at the most distant object ever seen in the universe, that red sort of puffy cloud. So obviously not a, majestic spiral galaxy. It's a bit of a blob, but it is nonetheless a galaxy. But it is unexpectedly massive and bright. It spans roughly 1,600 light years, so not very big, but it's already got around 500 million solar masses in stars, which obviously implies that it grew extremely rapidly in the first couple of 100 million years after the Big Bang. But a real surprise is that it's enriched with oxygen. And what this must mean is that there had been many generations of stars that had already lived and died before that 290, 300 million year period. There'd been many stars that had lived and died, a few generations of stars within that galaxy before that enriched it with oxygen. And this, according to our current models, we just can't explain it at the moment. There must have been multiple generations of stars that had lived and died in that galaxy in the first 300 million years after the Big Bang. And we don't have a clue how that could have happened.
May I make a comment? Just
of course you may.
So very, very interesting, Andy. In order to have that kind of turnaround, you would have to have, if we look at the universe that we have today, you'd have to have very massive stars, very short lifetimes.
Mm-hmm.
And so you have to have this anomalous situation where most stars, where a large number of stars were very massive and live their lives very quickly, as we would expect. I wonder if this might say something about the clumping of dark matter in the universe, which helped form the structure of these galaxies. Just a thought.
Yeah, it could be. Because, like you say, we know that at the beginning of the universe, or we assumed at the beginning of the universe, that the first stars that formed were massive, absolutely ginormous. So again, as Lou just said, they would have lived very short lives, but they would have gone on to enrich the environment that they had. So when they died. So it's a very interesting. Because this says it. Oh, you said it's 3 billion years after the Big Bang. Yeah.
I think the question to ask is, looking at the level of oxygen enrichment in the galaxy, how many stars would need to have lived and died? How many generations to reach that level of oxygen enrichment? So if they could measure the level of oxygen enrichment, which they probably have, and then work backwards from that and say, right, well, you'd need, I don't know, let's, for argument's sake, you'd need 1 million stars, 20 times the mass of the sun, living for 10 million years or something like that. I wonder whether you could actually be that accurate and work backwards, given the oxygen.
And how far after the Big Bang is the estimate of when this?
290 to 300 million years.
Okay, so the epoch of reionization is what, about 100 million years, right?
Yeah, that's right.
So there's your 10 generations of massive stars.
Yeah.
Yeah. So and of course, when we say that they were massive stars, how massive were they? Because we know that the biggest stars that exist today are, about the pun, but astronomical in size.
Yeah.
So it's where do you draw the limit? I mean, you can make an estimated guess, but That's fantastic.
Oh, there was some more bad news this week as well about an old star. Do you remember Earendel?
Yeah.
That star that sounded like something out of Lord of the Rings.
Yeah.
This was the star that was thought to be the oldest star ever detected, and it was detected through gravitational lensing. It was actually found in the arc of a galaxy in gravitational lensing, and scientists were really thrilled that that they detected this. Turns out now it's not a star at all; it's a cluster of stars.
Okay. Oh, what's
So,
that?
Well,
so
Yeah, 'cause I
unfortunately,
can remember.
that's buggered
I
that.
can remember all the fuss when
Yeah,
it
I
first
remember the
came
fuss
out. I can
with
remember the
Earendel.
images and thought, oh,
It's
that's
had such a
fantastic.
romantic name, the oldest star in the universe that we've detected, and it turns out to be a cluster of stars, which was why it was so bright. But there you are. You know, this is quite often science, isn't it? One step forward, two steps back, or two steps forward, one step back, depending. So there we are. So that's the news.
Just on the Hertzumsu question. The basically it's the Queen's University of Kingston in Canada that own the actual property, and what basically how they came about acquiring it was that on the site in the grounds of the castle, Hertzumsu Castle, that is where the observatory is, and that observatory was actually when Hertzumsu Castle was the home of Bader College, named after Alfred Bader, who was a luminous for Queen's, and he actually donated the site to them. That's how they got
Oh, I see.
That's how they got hold of it, and of course it was used as sort of like an exchange place, so that Canadian students could come here, and also European students could come here, because at the time we were linked with in the common. I was going to say the common market there. The European Union, and of course I suppose because we left, that sort of like became, it was so basically so Canadian students could work with students from all over Europe, and of course when we know that the cut-off point when we left, the tie was cut as regards students traveling back and forth from Europe, so it probably become less attractive, but obviously there's been some negotiation in the background. We've also rejoined some of the scientific things, haven't we now?
Yes.
And so they probably think, well, okay, then we'll really renew the lease on it. So yeah, that's how the Canadians got hold of it.
That's really interesting. Yeah. Okay, so let's move on. And in time-honored tradition, there's a man sitting here who's absolutely nearly wetting himself with anticipation of getting on the screen to do his weekly stint. I'm going to hand you over to the most capable and slightly damp hands of Roger now.
Yeah, that's not anticipation. That's his age.
I'm not incontinent, you know.
No, we're not in Europe anymore. No.
I don't know.
Okay. All right. Anyway, Roger, what's in the night sky?
Well, here we go through to the almost last week of August, although we are coming out to the bank holiday, which will be on the 25th, 4 months away from Christmas. Whoops, shouldn't have said that. And we're coming out through Friday for the new moon, so not too much to see in the night sky glow-wise. So if there is any clear skies, advantage of it. That's what I say. So through the week, we have got the fabulous constellations up there of Andromeda, and we've also got the Summer Triangle still blatantly shining overhead almost. And if you start to look over towards the northeast, we've got the Pleiades starting to come up through. So winter is coming, but not just yet. But we do have Saturn joining us quite nicely in the evenings now. So that's all well and good for anyone who would like to have a look at the ring planet. You can start to see that there is a tilt going on. So things are starting to get to make it look more like the planet we all love. But through the morning before the sunrise, we do have a little lineup. We have got Uranus down there, which is still in Taurus. We have got Jupiter and Venus coming up through, although last week was a better alignment for the two planets that were almost overhead to each other. And then we've got Mercury making an appearance, which is very nice. So here we've got the rising and setting of the planets as they come up through the morning. So all looking quite good. And on the 21st, on the Thursday, we've got Mercury at its highest altitude in the pre-dawn sky. So have a look for that if you have an opportunity for a low, clear eastern horizon, as well as Venus. So you've got Jupiter and Venus sort of pointing down towards Mercury, which will help because Mercury has always been a bit of a difficult object to see. So any little helps. There we go. Right, we do have a good gallery this week. Thank you to our contributors, and we've got a couple from Sandra. First one, which is the fireworks galaxy with her S30, the little baby brother, and this is 40 minutes. And we've also got an open star cluster NGC 6939 over in the top left-hand corner. And here we go. There we are.
Wow.
Actually, start to see the structure of the arms there. Very nice.
Yeah. That's beautiful, Sandra. Well done.
Yeah.
Well done.
That's a very faint galaxy, so that's very nice.
Yes.
And thank you for your donation, Sandra. Much appreciated.
Yes. And her second one, which is the dumbbell. And this is for an hour's imaging with the S30.
Oh, wow. That's
Lovely.
This,
all done with the baby brother, and you can get this.
Wow. They're really incredible, those sea stars. I'm definitely getting one.
Okay, right.
Yeah.
When they get up to about 150 millimeters, I might buy one.
Good luck carrying that out to the garden.
No, that'll be a permanent fixture. Don't worry.
I have to tell you all about this. The robotic telescopes I looked through this past weekend at a star party.
Yeah.
I love my sea star. I love my sea star, but I looked through one that I passed out, I think, after I looked at it. So we'll talk later.
What was that? 24-inch?
No, it was an Orion, I think, with a digital eyepiece.
Ah, right. Oh, the Pegasus eyepiece.
Maybe that's it.
Yeah. The eyepiece cost about £1,500.
Well, so what?
So what? Okay. So onwards with Jerry, and he's got the North American Nebula, and this was 25 times 5 minutes, and this is what he's produced. Wow.
Oh, that's nice.
Good definition
on those edges, isn't there? Yeah. Oh, that's cool. That is. I like that. Yeah.
Well done, Jerry. Very nice. And then, now this is a iPhone picture, 30-second iPhone picture.
Oh.
Of center halfway up, you can see the Andromeda Galaxy.
Galaxy, yeah.
And you can see the outline of the square of Pegasus over towards the right, almost as if it was tilted up.
Yeah.
Yes, you can.
And then further up towards the top left,
oh,
you've got Cassiopeia.
Yes.
Cassiopeia. Oh.
Yeah.
I see it.
Yeah.
I just Andromeda Galaxy as well. Brilliant that is.
I love the nebulosity in the foreground.
Yeah. It was a wee bit cloudy, but it got there. And that's just one 30-second exposure.
Oh,
excellent.
Wow.
Looking good. Right. And then I got some solar imaging done on Sunday. And it was just to get hold of this sort of prominence, which was lifting off the surface briefly there.
Mm.
The prominence.
Yes.
Mm. Looks like a
And,
sprite, doesn't it? The when you
yeah,
get
it does.
the lightning
Mm.
which goes upwards rather than
Up into the atmosphere.
yeah,
Yes.
beautiful.
Mm. Yeah, there's some quite good activity today, but it was too cloudy to capture it, which was a bit unfortunate. But maybe tomorrow. And then later that evening, I took a picture of this, which
Nice,
was about 2 o'clock in the morning.
Oh
And,
dear.
lovely.
it came out quite clear. I was quite pleased with that.
Lovely, that one.
Off. Okay. Oh, and I went through all my pictures of the Perseids. This was 2 days after the peak, and I managed to process this
Okay.
one,
Go on.
and I got that. Yeah, I mean the top part was almost completely blown out by the moon. It was that bright, so I had to sort of really give it a bit of a treatment. But
Well,
that
it's
worked out
there.
quite-
Yeah,
Yeah,
fantastic.
yeah.
That's good.
Yeah,
I didn't
out
see
of
a
about
one this year.
about 300 pictures, there was only 2, and they
Yeah.
were almost in the same spot.
Yeah, I didn't see any at all this year.
No, it's a bit
Yeah.
unfortunate. Right, we've got some from Tom.
Oh,
Now,
great.
this is part of Pickering's triangle. So he's only got around 3 hours for this one, which is a bit brief for him because he's usually about 18 plus hours on the picture. But this was done on his 8-inch Skywatcher Newtonian, so he had a reducer on there, so it brought it down to quite a short focal length and quite quick. So he managed to get. Wow.
Wow.
Oh, look at that.
Oh, that's lovely. Yep.
That's amazing.
Nice one.
Yeah.
Nice
Structure
one.
in that, isn't it? It's amazing.
It's a bit like the Pillars of Creation, isn't it?
Yeah.
Very much
All
so.
that structure.
Oh.
Yeah.
Wow.
Yeah.
That really.
And then just to top that off with another one of Tom's, part of the 6823 NGC in Vulpecula. So this was 9 hours of hydrogen, 6 hours of oxygen, and 4 hours of sulfur. So it's about 19 hours, which is about more normal for Tom. And this was what he got. Ooh.
Wow.
It's gorgeous.
Amazing as well.
Absolutely gorgeous.
The boy done good.
It's a bit like the elephant's trunk, that pillar coming up.
It is, isn't it?
Yeah.
And it's like the Pillars of Creation.
Yeah.
With the bot globules embedded in them.
I was just going to exactly say that. There's probably some protostars embedded in those towers and those sort of like thick tips at the end of strands and that. So there's probably a few protostars in there.
I expect so. And to top it off, this was one I did a couple of nights ago, but I only had the sulfur and oxygen filters on, and this is only 2 hours of integration time. So I made a false green channel with it, and it's not come out too bad. It was only done with my 130mm refractor, so it's only a 1000mm focal length, so it really would have needed a C11 or something with a much longer focal.
Wow.
But, I have done it before, but it can't
really
come out too bad.
Yeah, it's coming. Yeah, it's coming quite well.
Well, for only 2 hours, it's come out better than I thought.
Very good. Yeah.
I used to spend hours looking at the dumbbell nebula with my 4.5-inch Newtonian, and I got so good at knowing where it was, I could manually point the telescope right at it and get it almost in the center of the field of view every time. I'd observed it that many times. I knew exactly where to point the telescope. Yeah, those were the days.
So there we go for this week's gallery.
Thank you very much, Roger. Thank you as always, much appreciated. And thank you, viewers, for your images. And don't forget, if you would like to submit your images to the gallery, then all you have to do is to pop them in an email, attach them to an email, please, 1 image per email if you'd be so kind, and address the email to gallery@spaceoddities.space. And don't forget, if you do that, you also get your own little gallery on our website, which is https://spaceoddities.space. And you'll have your own gallery to impress your family and friends and passers-by on the street with. So there we are. And
I think, sorry, Andy, I think
yes.
also what Roger picked up with his phone just goes to show how good these phones are now. As I was saying last week, because we had a conjunction of Venus and Jupiter, and I took an image sort of like a day before it was actually going to get close, because cloud was coming in, took the opportunity with the phone. It was only sort of like about 3 or 4 seconds that I was able to take, and I didn't really think much of it because it didn't come, because it was, like I say, it was in the dawn, the sky was quite light and things like that. But I started to tinker around with it, and lo and behold, I swear that I've actually caught a phasing of Venus. The top of Venus looks as though it's almost flat. I've got a funny feeling I've actually caught some of the. I'd have to go back and check what phase it was in. But yeah, it definitely wasn't round, whereas Jupiter was. But it's surprising what you can actually pick up with these. The cameras now, and also as regards, you were talking about the new moon. Of course, this week on the 23rd, it's the new moon. It's actually a black moon. So we may get a chance to talk about that later. We'll see.
Which was also the title of an Emerson, Lake and Palmer album, believe it or not. Just sort of throw that in there.
Then.
Yeah, one of their later ones. Not good, but anyway. So there we are. That's the gallery. Thank you so much, as always, to Roger for guiding us around the night sky and for the weekly gallery. And, as Daz said, you don't need expensive equipment to, mind you, expensive iPhones cost a lot of money. But even with an Android phone, Android phone cameras are pretty good. I had to buy a new mobile last week because my previous one had died. And the camera on it looks really good. And I can't wait to, I want to go out and try and get some shots of the moon to see what the camera's like, astronomically speaking. So looking forward to that. And if they're any good, I shall submit them to the gallery, Rog. So there we are. All right, we're going to move on. Just before we do, a reminder that September is Mars month on Space Oddities. We're preparing a month of videos all about the planet Mars. We're going to try and make all our live streams in September all about the planet Mars as well. So if you've got anything about Mars that you would like to know or like us to cover, anything that you'd like more information about, then please don't hesitate to drop us a line. You can email us as ever at info@spaceoddities.space and tell us about it, or put it in the chat now if you would like to. But we're looking forward to bringing Mars Month to you in September a lot. We're all working very hard on creating videos for it that will appear on the channel. There is already a playlist called Mars Month on the channel, but it's empty at the moment, obviously, because we haven't reached September. But as soon as September hits, as you know, it's only a couple of weeks off now, we're going to be spending September telling you all about Mars. You may remember we did Moon Month in April, but was very successful. But obviously, we'd like to involve you. We're probably going to have a Mars quiz at some point in September on a Tuesday. So we'll quiz you all about the planet Mars. So that should be fun. We've got some special guests lined up for you. And we want to make the whole month fun for you viewers and tell you a lot about Mars. So if there's anything you would like us to cover in terms of Mars, don't hesitate to tell us, because we're here for you. You're our audience, and if you want to see things, we're more than happy to bring them to you. So Mars Month in September. We're going to move on now to Lou, and he's going to be telling us all about the tale of the Phantom Planet. Da, da, da. So
it sounds so exciting, but it's really rather nerdy. So,
Yeah, well, you have to make these things sound exciting because sooner or later somebody's going to watch our videos. So
we keep hope alive here on Space Oddities.
we do.
That's true. Hey, just to finish my story, I'd forgotten the name of the robotic telescope I looked through. It was an Equinox 2, and it has both a digital eyepiece on the telescope, and it sends the image also to your tablet or cell phone. And what I was seeing, just oh my goodness, C-Star 70 is going to have a big shoes to fill. Okay, more on that later. So there is a star system that is relatively close to us, only 4.3, 4.4 light years away. Sounds like a hop, skip, and a jump, until you realize that after traveling for almost 50 years, in 2027, actually exactly 50 years, the Voyager spacecraft will be 1 light day away. So, Alpha Centauri system, and it is a multiple star system, which we are going to get into in a moment. But let's see if we can identify it. So here we are. Here's the sky map of showing Alpha Centauri. It's in the southern hemisphere, so you have to be pretty far south to see it. You can see it right there next to the Southern Cross in the constellation of Centaurus. I don't think I may have seen it. I'm not sure. I remember going to Hawaii and thinking I saw it low on the horizon. But anyhow, it was one of the first stars at the time, to be for the distance to be figured out using parallax, and that was 1839. Something like that. Okay, so there it is. Now you know where to find it. And here's what it looks like. You can see it's kind of a graphic with our, if we put our sun at the center and then kind of indicate where the Oort cloud is. Of course, the Oort cloud has quite an extent, so that's just an average distance. And you come out 4 light years, and there is Alpha Centauri star system and Proxima Centauri. So there's Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Okay. So let's take a look at these 3 stars.
And Proxima Centauri is the one that is closest to us, isn't it? I think.
Yes, and hence the name. Good comment. Right. Okay. So here we have the 3 stars: Alpha Centauri A, B, Proxima, and compared to the sun, these images are to scale. Okay. So Proxima Centauri A is just a slightly bigger than the sun. Proxima Centauri B is slightly smaller than the sun. And Proxima Centauri is, sorry, am I saying Proxima? Alpha Centauri A, Alpha Centauri B, and Proxima Centauri is a small red giant, okay, class M. So, these are stars that could hold habitable planets. They don't have so much high energy radiation that would be precluded. And you can see their mass, their radius, their luminosities, and relative distances here. Okay. So not only is this a multiple star system, this is a multiple planet system. So over here for Proxima, you can see, so when we name planets, if you watch Space Oddities frequently, you'll remember that the first planet around another star is given the letter B. Okay, so Proxima Centauri has Proxima B, Proxima C, and Proxima D. And Proxima D is relatively recently observed, actually. I think it was confirmed in July, and it's roughly in the habitable zone of that planet. Then you have Alpha Centauri B, And it has one planet that has been discovered, a very smallish planet, about 1/10 the mass of Earth. And then you have Alpha Centauri A, B, right? Alpha Centauri A is the star and B is the planet. And this planet is kind of Saturn size. It's most likely a gas giant. I was interested to find out that the decision has been made that it's not tidally locked to Alpha Centauri A. And I thought, well, how in the world do you figure that out? And it turns out it's all very indirect and making kind of educated guesses based on its the star's age and the distance that the planet is from the star. So Alpha Centauri AB has recently been discovered, and more important, it has recently been confirmed by observations from the James Webb Space Telescope. So here we see 3 images of the star system. On the left, we see Alpha Centauri A and B as it appears optically in the Digital Sky Survey. In the middle, Hubble Space Telescope in optical light, we can see A and B fairly easily, those two stars. And then on the right, recent James Webb Space Telescope observation that used an occulting disk to shield Proxima Centauri. So you're shielding the bright star so it doesn't blow out your image. And over on the right here, you see what looks like kind of a bright blob. And it wasn't really clear what that was, but they've been able to model this planet using physics and modeling software, and they think it's a pretty good bet that this is a planet around Proxima Centauri. So this observation was made with James Webb's MIRI instrument. That's the mid-infrared instrument. And so the occulting disk is also called a coronagraph, and it enabled us to see the planet. Now, this new planet around Alpha Centauri A was a little hard to verify. It was described as both a disappearing planet, because sometimes it would be seen, sometimes not, or a phantom planet, hence the name of our slideshow today. There were some initial observations of this planet by James Webb in 2024, and it showed, a faint speck of light, pretty consistent with a planet of approximately Saturn's mass. Follow-up observations in February and April of this year did not detect the planet at all. So researchers used computer models to simulate millions of potential orbits, looking for this so-called planet. And the results suggest that in about half of the possible stable orbits that it could have, planet would have been too close to its star to be visible during those later observation periods. So that would explain why it appeared and disappeared. There were several rounds of Webb observations planned and very careful analysis done with the computer modeling to determine that this is indeed a planet and not a background object like a galaxy or a foreground object such as a passing asteroid or some other artifact. So we have a new planet in the Alpha Centauri star system, and I would be remiss if I didn't just mention that a new planet around Proxima Centauri has been discovered in the habitable zone, which we saw. The Proxima Centauri D was just verified in July. So this all brings the total number of exoplanets as spec'd out in the NASA Exoplanet Archive to 5,983. More to come.
Nearly the magic 6,000. Amazing.
Hey, we should have a special program for 6,000 exoplanets.
Oh, we definitely will, because that will be a real landmark. I remember when it was only 200 or fewer. Yeah,
I remember when we didn't know. Sorry.
Yeah, I remember when we didn't know as well. Yeah. absolutely amazing. Right. Well, thank you very much for that, Lou. This phantom planet, which was discovered and then lost and then discovered again. Just with regards to its orbit, Lou, those computer-modeled orbits. I mean, there's nothing really unusual about those orbits, I presume. It's just passing, behind its star or very close to the star, preventing us from seeing it.
Exactly. It's at about the distance, the orbit that they have selected after running all of these possible models says that it's about at the distance that Uranus would be in our solar system. So what's that, about 20 AU, I think?
20 AU, yeah.
Yeah.
Fantastic. Well, thank you so much for that. And indeed, when we reach the magic 6,000 exoplanets, we will definitely mark the occasion, as it were. It's very sad, really, isn't it, that so few people on this planet, realize these things are going on, and how far the science of exoplanets has come. And, the more we look at other solar systems, the stranger our own solar system becomes, because we've not found any solar system, as far as I'm aware, where you have the roughly the same spacing between the planets, the same distances, the same compositions. But we've talked about this before, but I think we need to get up to maybe the 20 or 30,000 mark exoplanets before we can start making any generalizations about the makeup of planetary systems, don't you think?
Well, I don't know. We have a database. We have 6,000 roughly exoplanets. We can start to say something.
Yes.
And the more planets you have, the more information, and you can start to really squish down that sigma in terms of understanding how planets form and develop. What I think is so great is that it really wasn't that long ago, some few decades, that it was thought that the possibility of detecting planets around another star was absolute fantasy, and anybody publishing theoretical work on how that would be done would be considered a kook.
Yeah,
and
absolutely.
Where we are today, it's just really astounding.
Absolutely, really astounding, and look how far we've come in just a few decades. It's it's I mean, if you look back to the 1990s, it's there were so many new discoveries during that decade that were just mind-blowing. Dark energy, for example, was another major discovery during the 90s. And when the first exoplanet was discovered, it was orbiting a pulsar, for God's sake.
Right.
Which everybody was going, that can't be. How could you have a planet orbiting a pulsar? Because there's obviously been a supernova explosion. How could any planet survive that? But
planet.
Yeah, it's that's how it is. The universe is always surprising us. So there we are. Thank you very much for that, Lou. Much appreciated. Going to move on now. I'm going to tell you now, we're going to carry on with our series of looking at new observatories that are coming online during the next decade, if you like. So we're going to be looking at the 30-metre telescope today, which has had an interesting history, to put it mildly. So let's have a look at the 30-metre telescope. Science, controversy, and a global future. And it says a journey through astronomy's most ambitious and contested project. So let's start by looking at the design of the telescope itself. I'm not going to spend too long over this, but obviously it's called the 30-metre telescope because it has a primary mirror 30 meters across, which is fairly massive. It's a segmented primary, like, all telescopes of this size have to have segmented mirrors, because the sheer weight of a single mirror 30 meters across would be far too much. The mirror would bend and distort, and also you can't use adaptive optics with a mirror that isn't segmented, but we'll talk about that. It's got a primary collecting mirror of 655 square meters. This is 9 times the light gathering power of the Keck Observatory, if you're familiar with the Keck, which is one of the world's big observatories. It's exceptionally versatile because it can go from near ultraviolet to mid-infrared. and that is that's a big range of wavelengths. So it's extremely versatile in the wavelengths of light that it can look at, and it will deliver, it's reckoned, images that are about 12 times sharper than the Hubble Space Telescope. As a comparison, the European Extremely Large Telescope, which we will be talking about in due course in this series, that is reckoned to deliver images that are 15 times the resolution of the Hubble Space Telescope, 15 times sharper. Either way, it's an incredibly sophisticated telescope with unprecedented clarity. But let's have a look at the timeline, because this is where it gets interesting. So we go right back to the beginning in the 1980s to 2000. This concept of the Extremely Large Telescope was recommended by the US National Academy of Sciences. And this was, part of their decadal survey into what American astronomy should do and build over the next decade. So from 2009 to 2014, China joined the International Observatory Consortium for the TMT, and they began constructing on Mauna Kea in Hawaii at an altitude of 4,050 meters. Don't forget, Mauna Kea has already got several large telescopes on it, because the seeing there is absolutely pristine. It's got incredibly dark, clear skies, which is why there's such a cluster of telescopes there, much as in the Atacama Desert in Chile with the European Southern Observatory, because the Atacama Desert has got the clearest, darkest skies in the world, where it goes for years and years and years without raining. So incredibly clear skies from the top of Mauna Kea on Hawaii. This was always the preferred site for the 30-meter telescope. But then things started to go wrong, because the native Hawaiians protested that the telescope should not be built there. The site they had chosen is on a sacred mountain. And because of the protests from the native Hawaiians, the Hawaii Supreme Court invalidates the permits for the construction due to procedural issues, but later reinstated them in 2018. But that didn't stop the problems, because in 2019 there were massive protests at the top of Mauna Kea on the access road. The police arrested 33 kupuna, which is the name for the Hawaiian elders. This drew global attention and protests that 33 Hawaiian elders had been arrested at the protests. And between 2023 and 2025, they formed a new oversight board to try and come to agreements with the local Hawaiians and hopefully get them to agree construction could go ahead. But then in June of this year, funding was withdrawn altogether from the project, because as you know, in the United States, science is under attack. The Trump administration is trying to destroy science as fast as they can. The NSF, realize that they're not going to have the money to build not just the 30-meter telescope, but also in Chile, the Giant Magellan Telescope, which is another project. So they've completely withdrawn funding from the TMT. So whatever happens, the project in its current form is not going to happen on Hawaii, unless something changes in the funding, which in the short term, it's definitely not going to. So the Hawaiian opposition, because the Mauna Kea is sacred, they said that the site had got too many observatories there already, and it was offensive to Hawaiians, which for them it's a sacred site. It represents the meeting place of Papa, the Earth Mother, and Wakea, the Sky Father. It's a sacred realm reserved for ceremonies and deities. Also, it's home to threatened species and delicate ecosystems, with concerns about groundwater contamination and habitat disruption. And in all the court hearings about this, the people who were designing the observatory said, no, we're going to have a totally self-contained system. There's going to be no groundwater contamination, no habitat disruption. We're going to guarantee that. But that did little to placate the native Hawaiians. And also, it brings up larger issues about Hawaiian sovereignty and historical land rights, because, you know, the Hawaiians say, look, this is our land, it's sacred to us, you just can't come in and keep building telescopes on a place that is sacred to us. So that's where it stood. Just go briefly through the opposition movement, initial blockade, halts construction. The Hawaiian Supreme Court invalidates the building permits, ruling that the state had failed to follow proper procedures when giving information. The thousands of people blocking the access road in 2019, the arrest of the 33 elders. The UN, nonetheless an august body than the UN Committee on the Elimination of Racial Discrimination, criticized the project for ignoring native Hawaiian consent in 2021. And Section 106 consultations involve hundreds of community voices opposing the TMT, leading to a new governance model. The funding crisis has come about because, you know, as we've said many times, the National Science Foundation is facing massive cuts under the Trump administration, not just to astronomy, but across all of science. And they faced a difficult choice, and they were left only to fund one extremely large telescope project. And they highlighted in 2024 an existential threat due to the site access issues, because the protests have not stopped. The access road had continued to be blocked. So they were really worried about whether the project could go ahead, budget cuts notwithstanding. And then, of course, in June, funding was officially removed. But the TNT project manager was optimistic that they could move the project forward by finding alternative funding. But then in July, Spain stepped forward and said, hang on a minute, we think we can help out here. We will make up the funding shortfall if the telescope is built on La Palma in the Canary Islands, where Spain has several large telescopes. And it was a bold proposal. And it has been well received by the TMT project. They are looking at it. And if this can go ahead and they agree to it, then it's absolutely brilliant that Spain can get this telescope built. And they've pledged up to 400 million euros, or $471 million, to relocate the telescope to La Palma in the Canary Islands. Now, the site on the Canary Islands, the seeing there is not as good as it is at the top of Mauna Kea. The skies are not quite so good, but there's not much difference between them. And if you do sort of swings and roundabouts analysis, as I have, as to which site is actually better, there's very little to choose between them. They each have their pros and cons. So it wouldn't be as if relocating the telescope to La Palma would mean that the astronomy would not be as good. It would be. So this is very exciting. They've already got several major telescopes on La Palma, as I said, at the Roque de los Muchachos Observatory, and Spain are, you know, well used to managing these types of projects. It's about 2,000 meters lower in altitude than Mauna Kea, but is still excellent. And the offer includes decades of scientific operations support and social benefits for the island. This is a very, very good offer. And the La Palma site was always the backup site for Hawaii in case anything went wrong, as it did. They had a backup site of La Palma originally anyway. So this is not something that is new. It just means using a backup site effectively. So Spain is actually putting itself forward to become not, as it says here, a global center for astronomy. Spain wants to be the global center for astronomy. They've already got the Teide Observatory on Tenerife, as I said, the Roque de los Muchachos on La Palma, and Cala Alto Observatory in Andalusia in the south of Spain. And this will be the crowning glory for Spanish astronomy and establish Spain as a leader in the next generation of astronomy. And the Diana Morón, the Spanish science minister, says this represents a historic opportunity for Spanish science. By hosting the TMT will not only advance global astronomical knowledge, but also create hundreds of high-skilled jobs and establish Spain as the European gateway to the cosmos. We've developed a comprehensive plan that addresses both scientific excellence and community integration. La Palma offers ideal conditions, whilst our investment demonstrates Spain's commitment to frontier science. So Spain really do want to become ultimately the global center for astronomy. And there's another quote as well. Spain wants to be and can be the home of the future of astronomy and astrophysics. We have the capacity and the political will to do so. While some countries are cutting back on investment in research or stopping it altogether, no prizes for guessing which country she's talking about, Spain is a haven for science. And the Secretary of State for Science, Innovation and Universities said, we want the sky of the Canary Islands to be the great astronomical reserve of the planet. So Spain are really, really keen, not just for the observatory, but to integrate the observatory into science education and research. So this is really, really good news. To be honest, I would be very surprised if this offer were rejected by the TMT. As I said, for start, La Palma was always the backup plan. And at least with Spain's offer, it means the telescope will actually get built. And it's something well within the technical capability of the Spanish, who are used to building these big telescopes. So I think, they'd be crazy to reject this offer. Just as another indication of how serious Spain are about astronomy, the Council of Ministers, which is, if you like, Spain's cabinet, they created an interministerial commission involving 13 ministries, co-led by the Science and Transport Ministries, to coordinate Spain's 2026 to 2028 solar eclipse trilogy. Because in Spain, we've got 3 solar eclipses 3 years running. We've got two total eclipses, one in August next year in Spain, one in August 2027 in Spain, and another one which I think is only visible from the Canaries the year after. I think that's well, somebody could check that, but I think that's what it is. So they're framing astronomy as a national priority, with implications for science, tourism, education, and infrastructure. So this is great news, and let's hope that the TMT consortium accept this offer, so construction can start, as they said, perhaps even next year. The construction can start on this mammoth telescope on La Palma in the Canary Islands, and this is just a very quick comparison between the two sites: altitude, atmospheric water vapor, air stability, clear sky nights. And as you can see, you're not losing much, if anything at all. If you do a deeper analysis, which I did just to get an idea of what the differences were between these two sites, as I said, it swings and roundabouts. They come out virtually the same. Each has got their pros and cons. So the scientific stakes behind this: the TMT promises revolutionary insights into the earliest galaxies and stars, dark matter and dark energy, gathering data to understand those conundra, exoplanet atmospheres, directly analyzing the chemical composition of planets around other stars, and studying physics near supermassive black holes, extreme gravity near supermassive black holes at unprecedented resolution. So this is great. But obviously there's some lessons to be learned from this whole saga of the TMT. Scientific projects must engage meaningfully with indigenous communities from the outset. The cultural significance of science requires the same attention as scientific criteria. Transparent governance and shared decision making are essential. The TMT controversy has actually transformed how science engages with indigenous knowledge and rights globally. So, you know, every cloud has a silver lining. If it means that the planning and construction of these big observatories in the future takes a lot more notice of local concerns, as it were, that's really got to be a good thing. The future of the telescope depends on securing stable international funding, building genuine community partnerships, balancing scientific ambition with cultural respect, demonstrating tangible benefits for the local populations. So, although it says here that its future is uncertain, you know, this offer from the Spanish has not been accepted yet. As it says, as Spain extends its hand and Hawaii holds firm to its cultural heritage, the story of the TMT reminds us that the greatest scientific achievements must harmonize with the deepest human values. However, obviously, the quest to understand our universe continues, transformed by the voices of those who remind us that how we pursue knowledge matters as much as what we discover. So there you are. So that is the story of the 30-meter telescope. So what do you think, guys? It's exciting, isn't it, that this telescope may be saved after all?
It is very exciting. A few years ago, 3, maybe 4 years ago, I was in Hawaii with Susan, and we went to the access road to Mauna Kea. There were tents set up all over the place. There were tents set up on the access road, and they were doing some cultural dances on the access road. So there's no way to get in. But they had a tent dedicated to information for people who are interested. So I walked over. The beliefs that these people have, and I don't know if they represent the majority of Hawaiians, but the beliefs that they had were rather crazy. That it was somehow tied into nuclear testing on Hawaii, that nuclear waste would be bleeding out from the telescope and polluting their rainwater and other things like this. So I tried to say, no, that's not going to happen. But I think my view of this is it's probably in the minority. My view of this is that this is not the first time, nor I suspect the last, where religion, or depending upon where you sit, magical thinking has put a stopper in the pursuit of science. So I'm thrilled that Spain is making this offer. My head is off to Spain. I'm going to Spain next year for the eclipse, and I will make sure to thank everybody I pass.
Right.
Yeah, because you say about the Hawaii escapades. There was also, yes, I mean, it all was based on religious grounds and the beliefs of the Hawaiians. But also, when they were first given permission to build the telescopes, there was a provision where they could only have so much acreage for the telescopes.
Right.
And but when the telescope was decommissioned, that ground had to be completely cleared, and that meant of foundations and buildings and everything to return it back to nature. But like I say, there's only a certain amount of footage that these telescopes can take up. Well, they've decommissioned quite a few telescopes, but they didn't honor that part of the agreement, and it's actually been left as that hasn't been turned back to nature. And this was one of the reasons as well why they were talking about it. As regards to the nuclear stuff and all that, conspiracy theories are always sound good, don't they, when you're having a protest? Yeah, so like you say, it's good that the now indigenous, I mean, especially in Australia, They've got firing ranges on Aboriginal land, and they have to have permission from the local Aborigines to be able to operate from there. And if they fire a sounding rocket, they then got to go off over the next few days and recover every single piece of that rocket when it's returned. So it's good that this is all happening, because I mean, when it's good for the environment and all that. Yeah, it's but also, I swear somewhere you were talking about, Andy, and because I read about this the saving the 30-metre, and I thought, oh, that's absolutely fantastic. And I think when we did the telescopes on the radio, we did mention that La Palma was a backup for the 30-metre.
Yes, we did.
Because I got a funny feeling, wasn't there was actual talk at one time of building two, one in Hawaii and one in La Palma.
There was, indeed, does. Yes.
Yeah.
Yes.
And then of course they thought, well, we can only afford one, so we'll go to Hawaii, which was disappointing for the Northern Hemisphere, but you know, it's say la vie. But now we may get it. But also, I swear, I'm sure I didn't dream it, I didn't imagine it, but Spain have also offered to save one of the space telescopes that's due to be decommissioned.
Oh, I haven't heard.
Has been commissioned. Yeah, it was. I only saw it the once. I don't know whether it was just, you know, just somebody mentioned that they might do it, and of course then it hit, somebody took it and ran with it. But I haven't heard anything since. But they were also talking about saving one of the decommissioned telescopes, or one that's due to be decommissioned. I don't know whether it was Gaia or someone like Kepler or whatever. I don't know. They were talking about saving, possibly taking on the running costs of one of these, because these satellites could be quite easily commissioned to do other sort of science and things like that.
Yes, absolutely.
So but I was glad that people are actually stepping up now and saying that we need these resources. I mean, X-ray telescopes in space, we're desperate for.
Yeah.
So we've got a couple, but they're only small. They're not the big ones like we've had in the past.
And Chandra is very much under threat.
Yeah, I'm not sure. Chandra may be the one that I'm thinking of. It's either Chandra or Gaia.
Well, I'll research that and find out.
Yeah, I may have dreamt it. I don't know, but I'm sure I didn't. But yeah, but it's great that they're stepping in and they are going to save this. Which should be a wonderful asset. That we thought we weren't going to get a look in at all. And we need some bigger telescopes up north anyway.
Gracias por la telescopio 30 metros. I get it right?
El Telescopio, it's masculine.
El Telescopio.
Yeah, I always fall foul of that, Luke.
Okay, I'm going to practice that.
Yeah. I mean, I'm quite linguistic. I can speak several languages. I've got Australian, New Zealand, you know, American,
and obscene.
Come over here and speak Southern. I want to see that.
Yeah.
But I'm really thrilled, being a Spanish resident, that Spain is really committed to making astronomy a national priority.
Good news, that is. Yeah,
it's great news, because it wasn't always the case. We have quite a in some ways progressive socialist government who are very, very keen on particularly science education, and this is such a wonderful educational opportunity apart from anything else. So well done, Spain, and I think it's all quite wonderful. Everything is quite wonderful, but there we are.
I mean, the thing is, just one thing, and I don't want to get into the politics of it, but the basic real attack on space science in the US is in danger of leaving America in the backwaters of space if they're not careful. Because I mean, Lou can testify for this. They've sacked so many scientists, even graduates who were on courses there. And if they can't practice their work there, they're going to go somewhere else. So people like Spain, Europe, and everywhere else will pick up these people, and they will become the driving forces in space.
Yeah.
Which is the thing is, like I say, from 1960s when they put a man on the moon to what we're seeing happening now, it's a sad state of affairs.
It's a very sad story. It's a very, very sad
but that's all I'm going to say on it. I don't want to get political.
There's good news in America because the news media isn't allowed to report on anything scientific. So we won't know, we won't feel the pain. We'll just same old company.
Yeah, good grief. It's the darkness has got to lift sooner or later, Lou. It really has to. It really has to. I'm optimistic that even within the next year, the darkness will lift. I'm quite certain about that, the way things are going. All right, let's move on. Let's have something happy now. Oh, God, no, it's Michael next. Sorry.
Hey.
Yeah. Anyway, hello, Michael.
Hello, Andy.
Hope you're well, old chap.
Yep. Wonderful.
So you meant to say radiant, sir? Radiant.
Ah, yes.
So we're going to go to Michael now, and Michael is going to deliver this week's Constellation of the Week. So
yes, I am, very shortly. If you just bear with me.
Take it away, Michael. While Michael gets himself together, perhaps you can help us out, viewers. We're having a chat after last week's show. We're worried that we might be detaining you on Tuesday evenings for too long. In other words, that our shows might be a little bit too long. And we would like your thoughts now. And do you think that our Tuesday live streams are too long? Would you prefer a show of, say, just 1 hour? Would you like a show? We're running about 2 hours per live stream on a Tuesday at the moment. Do you think that's about right? Would you prefer to see longer live streams on the other hand, which, astronomy being astronomy, would certainly have enough material to fill that time, interestingly. So what do you think, viewers? Do you think our live streams are about the right length? Do you think they're too long, too short? What do you think? And if you've got any comments, if you could put them in the chat now before we go over to Michael. Lou, yeah, very good. It looks like it's written backwards, but it is Welsh. So there we are.
Yeah, but can Lou pronounce it?
No, obviously not. Anyway, please, viewers, help us out with this because we need your input on this. And Derek says 2 hours would be great. So, in other words, keep it at the same. No more comments. Come on, guys. We really need you to give us some feedback here.
Would you like possibly more? Maybe another show, two shorter shows to make up.
Yeah,
2 hours.
We could perhaps do 2 1-hour shows per week.
Yeah.
Nobody got any views? Nobody? Right. Okay.
Oh dear.
I'm just going to wait and see. Right. Kev says, Gerard says it takes as long as it takes. That's real science. Kev says length is okay. If I need to leave, I do. Fair enough. Fair comment, Kev. Paul says live stream is about right. Also flexible depending on what everyone's discussing. Yep, very true. Anne says, thank you, Lou, in Welsh. Stuart says, 2 hours is fine by me. Derek says 1 show a week. Ian says 2 hours is fine. We can come and go over, please, if something isn't as interesting. Okay.
Right.
So, yeah. Well, I think the eyes have it, basically, then, don't they? We'll keep things as they are.
But what does dial mean?
Oh, Alan's just said 1 hour to 90 minutes max.
Yeah, yes to 2 shorter shows.
Sandra said all-nighters.
I assume we're talking about the live stream, Sandra. Those days are long past for me, I'm afraid.
We'll do an all-nighter, Sandra, if you stay up with us.
Yeah.
We could go 24/7.
Seriously,
I hope you're referring to Star Party all-nighters.
Yeah, Sandra says, seriously, I think it's fine. Carl, thank you, Carl, says fine, 2 hours. Right, well, we will take that under advisement, as they say. Derek says, if it ain't broke, don't fix it. Wise words, Derek. Wise words. And I hope you had a lovely birthday, Derek, by the way. So there we are. Right. Okay, I think that's just about I think that's just about done it. Yes, of course I will. Yes, of course you were, Sandra. Yes, wink, wink, nudge, nudge. So yes. So there we are. All right then, let's move on. Yes, we're going to Michael, weren't we?
We are,
Michael,
yes.
Constellation of the week.
Yes.
The ball is in your court, sir.
Make us proud, Michael.
Make us proud.
Right. Have you got that?
Yes, we have.
Brilliant. Tonight we're going to talk about Delphinus, the celestial dolphin, a small but distinctive constellation in the northern sky. Delphinus has captivated stargazers for millennia with its charming dolphin shape and rich mythical heritage. Here's a detailed view of the constellation. Very small constellation, only 5 stars that make up the actual pattern. But here it is depicted as a dolphin in the night sky, which I'll come on to shortly. When I took this from Stellarium recently, you can see that Pallas is also traversing through the constellation. So, okay, shape and location. Delphinus is instantly recognizable by its graceful kite-shaped asterism called Job's Coffin. I've not heard that before. Formed by 5 main stars outlining a dolphin leaping through the sky. Positioned near the celestial equator, the constellation is visible from latitudes from plus 90 to minus 70 degrees, with September evenings offering the best viewing opportunity. I think that means within the northern hemisphere, really. But yeah, so it should be visible now anyway, and it'll be coming up better next month. It borders 6 constellations: Vulpecula, Sagitta, Aquila, Aquarius, Equus, and Pegasus. And here's a diagram again from Stellarium to show that. I don't know if you can see my cursor. Can you see my cursor?
Yeah.
Yeah.
Yeah. Delphinus is this small constellation here. This is Equus. Pardon?
Small but perfectly formed.
That's right. And you got the Milky Way flowing through there. And as I say, you got Cygnus at the top there, Aquila, Aquarius and Capricornus, and Pegasus and Lacerta there that I talked about a couple of weeks ago. So that's the location really. The dolphins in the stars. One of the mythological ideas from about Delphinus is Poseidon's messenger. Greek myth tells of a loyal dolphin who served as Poseidon's messenger. The dolphin found in the shy nymph Amphitrite and persuaded her to marry the sea god. And as thanks for the service, Poseidon placed the dolphin amongst the stars.
That was nice of him.
Another one is Arian's Saver. Another tale, he recounts how the poet Arian was saved by the dolphin after being thrown overboard by the mutinous sailors. Charmed by Arian's music, the dolphin carried himself safely to the shore, earning its place in the heavens. Symbolic meaning throughout the myths, dolphin embodies loyalty, rescue, and connection to the sea. So, go on with that. In culture, the Delphinus belongs to the Heavenly Waters family of constellations, linked to water and the sea themes alongside Carina, Columba, Equus, Eridanus, Pisces, Australis, Puppis, Pyxis, and Vela. Vela historically formed part of the former constellation of Argo Navis, which in Greek tradition represented the ship of Jason. And here's a diagram, a drawing of Jason's ship Argo Navis there from ancient times. Recognised since Ptolemy's 2nd century catalogue, it remains one of the 88 modern constellations officially recognised by the International Astronomical Union. Beyond Greek tradition, Delphinus appears in various cultural contexts. In Chinese astronomy, as part of the Black Tortoise of the North, within Polynesian navigational traditions, and also found in Hindu astronomical texts. Brightest stars. Once again, Alpha Delphinus is not the brightest star in the constellation. That falls to Beta Delphini, or otherwise known as Rotanev. The brightest star in Delphinus with a magnitude of 3.6. It is a binary star system located 101 light years from Earth. Name is Venator, spelled backwards, which is Latin for hunter.
Some wag having some fun there, obviously.
Yes, that's right. I'll come on to that in a little bit as well. Then we got Alpha Delphini,
Swallowsin,
which is not very easy to say.
No.
And again, it's the second brightest star at magnitude 3.8. It's a multiple star system, 254 light years distance. Again, the name is Nicholas reversed, honouring astronomer Niccolo Cacciatore from Italy.
No, really.
Yeah, Cacciatore.
Eh.
Then we got Gamma, Delta, and Epsilon complete the dolphin's distinctive shape. Gamma and Delta form part of the dolphin body, and Epsilon marks the tail of the dolphin. Okay, here we go about the puzzle of star names. Both star names, Rotanev and Soiloshin, whatever how you pronounce it, are reverse spellings of the Latinized name and first name of astronomer Niccolo Cacciatore, otherwise known as Nicolas Venator. Here he is.
Oh, he looks a fun chap.
Yeah. Cacciatore was working at the Palermo Observatory in Sicily when these names appeared in the Palermo Star Catalogue of 1814. Discovery of the deception, the clever wordplay wasn't decoded until English astronomer Thomas Webb revealed it in 1859, decades after the names had been established. This playful naming reflects the human side of astronomy's history and shows how even serious scientific endeavours can include moments of whimsy and personality. Aren't we all the same?
Well, absolutely.
It looks like he's been in a car accident. He's wearing a neck brace, isn't he?
Yeah, all right.
Bless him.
Okay, so deep sky treasures in Delphinus. Short of a handful. We've got NGC 6934, which is a globular cluster shining at magnitude 8.9, located near the dolphin's tail. This ancient collection of stars requires a medium-sized telescope to observe in detail. And this is a Hubble Space Telescope image, so, take that how you want to. Very similar one here, NGC 7006, another globular cluster, fainter at magnitude 10.6, found near the dolphin's nose. It's notably distant at approximately 135,000 light years from Earth. Yeah. Okay. Yeah. Right. And then we have NGC 6891.
Oh, that's beautiful.
It is. It's a planetary. All I've got on it is it's a planetary nebula with complex structures. It's a nice one.
We don't know the magnitude or distance. Or
no, I didn't get that. So I can find that out.
It's beautiful, though, isn't it?
And another one is NGC 6905, which is also known as the Blue Flash Nebula, particularly notable for its bright blue glow and the intricate shells of expelled stellar material. So those are the deep sky treasures.
Wow.
Exoplanets, despite its small size, Delphinus hosts at least 5 stars with confirmed exoplanets, including the notable star Sharma HAT-P-23, a G-type main sequence star almost 1,200 light years away. But also in 2010, a transiting hot Jupiter-like planet was detected. It has a measured day-side temperature of more than 2,100 Kelvin. The planet is believed to be on an unstable orbit and expected to be engulfed by its parent star in about 7.5 million years from now.
Don't wait up.
Of course it is.
Yeah. Wow.
Okay, so as I say, just as a conclusion, though faint and small, ranking 69th in size amongst the 88 constellations, Delphinus captivates with its rich mythology, stellar wonders, and exoplanetary intrigue. This celestial dolphin serves as a reminder that even the smallest patches of sky hold rich tales and cosmic mysteries waiting to be explored. And I haven't physically looked at it myself personally for a long time, but I do remember in late summer looking at the sky in that area. It is quite, although the stars are quite faint as constellation stars go, it does really stand out near the Milky Way on a really good dark night. So, and that's my memory of it, if you like.
Wow, there we are.
And that's it.
Thank you very much, Michael.
Yeah, its magnitude is 10.553.
Which?
That the little
Oh yeah, the little planetary.
Yeah, planetary nebulae
Yeah,
shows.
okay.
Right. Thank you for that,
Yeah,
guys.
thank you for that.
So within the reach of small telescopes.
Yeah.
Just to go over a couple of comments here. Derek says, I think naming stars and constellations depended on what they were drinking, smoking at the time. I think we'd all go along with that.
No doubt.
So Derek says, bearing in mind what we've just said about the length of our live streams, 20 minutes to go, chaps. So
Very good.
thank you, Derek, for being the voice of reason and keeping an eye on us with your ever reliable stopwatch. So there we are. So basically, thank you all for your input. Looks like we'll be keeping the show at 2 hours. Thank you. It really is much appreciated that you give us our views as ever, because we're always conscious of overstaying our welcome, as it were.
If you think about it as well, 2 hours is usually the length of a usual astronomical society meeting. So
yeah, that's right. And God knows I've fallen asleep in enough of those.
And me.
Yeah.
So,
But some of that's taken out with coffee and biscuits.
That's true.
Yeah, but we're a lot more fun.
I've had mine, Daz. Look.
I'm due for a refill, and Sandra, yet again I've got a mug here without a handle. So there we are. So I'm going to start buy Andy some coffee mug handle crowdfunding if you're interested.
Yeah.
So just for you the handles.
just the handles. Yeah. So thank you very much for your input. We will keep things as they are. So as not to upset Derek, we better move on, I suppose.
Yeah, definitely.
I don't know. Give people an inch and they take a bloody liberty.
Yeah.
So just to finish off this evening, yes, it's back. It's time for Einstein of the Week, our regular, not quite weekly, delve into the undergarments of the internet to find out what lies beneath. And as I said earlier, some weeks we don't do Constellation of Einstein of the Week because, there hasn't been anything notable that would entertain you for your delectation and delight. But this week has been a bumper week for sheer unbridled lunacy. So let us move on, gentle viewers, and find out what's been going on social media this week. And I hope you'll agree that this is a bit of a blinder this week. Without any more ado, let's move on to Einstein of the week. So Einstein of the week. So in reverse order, coming in at number 15.
15.
Now, 15 this week. Yeah, I did warn you. So this is to do with the comet again, Comet 3i Atlas. And just to show you how bad things are on YouTube, there's a guy who's posted this video on YouTube. Humanity is not ready. 3i Atlas is a super intelligence from deep space. And this is a guy called Stefan Burns, who is actually a practicing geophysicist who's highly qualified.
Yeah, I know him.
You know him?
Yeah, I've heard of him, yeah.
Yeah, and he keeps, although he's, you know, obviously an extremely intelligent guy, highly qualified, works in geophysics, a string of qualifications, has done lots of, you know, science education, he's decided to come up with crap. You can only assume it's all clickbait, but if you look at the comments in these videos, people just swallow it hook, line, and sinker. And they go into this fantasy world. Thank you, Avi Loeb, for starting all this nonsense about the comet being an alien spaceship. Avi is, you know, a David Icke type character who was once upon a time a credible scientist and has done lots of valuable work, but he's come up with this thing that, oh, it's an alien spaceship. And the internet's just gone mad over it. And this is just an example of what we're up about. We are the direct antithesis of what this is about. We are all about science and teaching people about real science, not this crap. So sorry, Stefan Burns. He makes videos about quantum consciousness, human souls, plasma transformations, you name it. He's laughing at his audience. He must be, because he's a highly educated guy. But this goes very much against the grain of what we try and achieve. And unfortunately, he gets millions of views on his videos, and we don't. So that's the frustrating thing, that we're trying to do real science here on Space Oddities to entertain and educate you about the universe. And somebody can post a video like this and it gets millions of views.
Yeah,
So,
but Andy, you can remember we've seen other people who seemed quite rational and all that basically turn to the dark side, and basically it's because that's where the money's made.
yeah, and the person we're talking about posted a video today saying that an artificial light had been sighted on the comet.
Oh, okay.
Yeah.
Artificial light.
Yeah.
Yeah.
Somebody,
yeah.
I couldn't lower myself to actually watch the video because I'd be tearing what little hair I have out.
Yeah.
But that was the type of the video: artificial light spotted on the comet. So this is what we're up against, chaps, which is why we need you to spread the word about Space Oddities. We've got to counter all this nonsense. Anyway, let's move on. Let's have some more fun. Number 14, fake. I've called this one. And it's somebody, you know, giving their opinions about planets and stars. Fake. No such thing as space. All those stars and planets are tiny lights in the sky dome over the stationary flat plane of Earth. It's like tiny lights on the ceiling. So this is
right.
Yeah. So this is a typical flat earther. They go on about this dome over the Earth. They get rabbit on about the firmament, when firmament is just another name for sky, which none of them seem to realize. But again, this is what we're up against. This guy, you know, you can see this was on Facebook that he got so far 7 people laughing at it. But you know, there are so many of these people.
He's probably got lights on his ceiling.
Yeah.
He's only 400 or more years behind. Don't be too hard on him.
Exactly. Yeah, I was just going to say, in the past, that's what it was.
The stars were lights in heaven, glued somehow to a crystalline sphere. I mean,
yeah, absolutely.
Give him some time.
So, yeah.
In some societies, they used to think that these stars were holes punching the fabric of the dome, where the souls would pass through of the ancient of their ancestors. So yeah.
Souls. So
yeah.
Anyway, so that's that one. 13. Somebody talking about the origins of the Russian earthquake. This is an interesting one. totally main cause, dams too many. I think he means dams too many. All the extra weight of water is changing Earth's core, triggering earthquakes and volcanoes.
Huh.
Yeah, all that extra water.
Yeah.
What can you say? I did, gently say that he's got it the wrong way around, that the earthquake is obviously tectonic, causing the volcanoes and not the other way around. But certainly nothing to do with dams. So there we are. Coming in at number 12, the Reader's Digest universe. This was from a lady who said, I read in Reader's Digest way back 30 years ago that our Earth was like 85 years old. In light years, that is million years from now. That is why planets are aligning one after another. The meteorites are falling by the hundreds. How exciting.
What?
So we got to blame Reader's Digest for this.
It's
Gotta
quite a
blame
dream.
Reader's
Yeah.
Yeah. My parents used to get Reader's Digest magazine when I was young, and I never recall them stating that the Earth was like 85 years old.
Yeah.
So
I wonder if she's older than 85.
I wonder.
Icing
I
on the
don't understand the next sentence. In light years, that is million years from now.
Well,
So-
she's only got to be over sort of like, say, 35-ish for her to be able to read the digest. So, we're talking, okay, we're not going to go into
She
this.
doesn't understand. She doesn't understand light years. They're just like regular years, only they're less filling.
Yeah.
we haven't got time here if we have to leave.
Yeah, absolutely. Okay, coming in at number 11. On Facebook, somebody posted a rather neat CGI video to illustrate gravity of black holes. And this was a guy's comment. These videos look like they were computer generated, not authentic from a camcorder.
What?
Yeah.
A camcorder L2.
Exactly.
Yeah.
Exactly.
I did point out to him, yes, of course they're computer generated. The closest black hole is about 2,000 light years away. How do you propose getting a camcorder 2,000 light years away?
Yeah.
Yeah. So
It's going to change the cartridge.
Technology is evolving, apparently.
Yeah, and how would you run a battery for the charger over 2,000 light years? So so there you are. Okay, that one I was completely stumped by. Number 10, that's not how it works. I love this one. So when your brother sends you a sunset photo from New Zealand and you send a sunrise photo from Scotland, and you realize you're looking at two sides of the same sun from opposite ends of the world.
Two sides of the same sun.
Two sides of the same sun.
So one's looking at the far side and one's looking at the near side.
Yeah, exactly. That's really
it's for, right?
Sorry?
That's what the stereo mission was for.
Yes, that's right.
Exactly. Yeah,
that's right. Absolutely. Yeah.
And it's only the solar orbiter that can look around the back.
Yeah, absolutely. But that really isn't how it works.
No.
Okay. So there was an article about moonquakes, a quite interesting article about what we've learned about the moon since the first seismometers were placed on the moon during the Apollo era. And somebody got really concerned about these moonquakes happening on the moon. He said, what about the waves that comes after the quakes? How high is it there? Yes, the tsunamis.
Oh, that's a good one. I like that.
Well, the thing is, they are seas, Andy. They are seas.
They are seas. Yes, very true.
Yeah.
Perhaps he's taking it a bit too literally. But
Surf's up, dude, on the moon. Surf's
up. Somebody not understanding how the globe works.
Dear me.
Can someone explain why Putin and Trump met all the way in Alaska when Washington, D.C. is literally on the way?
I like that, definitely.
Yeah.
So sad.
I know, somebody really not understanding how the globe works. But,
What wasn't Alaska part of Russia originally?
yes, I know. I know.
Yeah,
Trump's just given it back, probably.
yeah, probably.
So there we are. Okay, number 7. Simply Oscar.
Oh,
It's that white moon dust doesn't cover the rocks and Oscar Armstrong's footprints.
what?
Oscar.
Who's Oscar?
Oscar Armstrong. Yeah,
Oscar Armstrong.
yeah.
Well, I
I
wonder
wonder what the
they're
original
referring to.
question was.
Yeah.
It was simply about the behavior of dust on the moon. It was just a little article in a astronomy page on Facebook. So he's basically trying to say the moon landings were fake because the moon dust doesn't cover the rocks.
Doesn't cover the
Doesn't
rocks
cover the
or
footprint.
Oscar's
Oscar's footprint.
footprints.
Yeah. So there you
Okay.
are. You heard it here first. First man on the moon, Oscar Armstrong. Louis'
I
brother.
can see why he changed it to Neil.
Yeah.
Ah,
Yeah. Yes, Louis' brother, obviously.
Yes.
Yeah.
So there's Oscar. Number 6, there no air in space. How come there's no air in space? Earth, sure, we have inner core that create carbon dioxide, but space, shrug. Maybe we all live in a bottle cap. Lol. I'm just
What?
intrigued as to how the inner core creates carbon dioxide, actually.
I was almost following him until he came to the bottle cap. I'm not sure
Yeah. Yeah.
what idea what that's about.
Yeah. So there we are. Coming in at number 5, somebody talking about scientific evidence. This is so interesting because all of this new scientific evidence is ancient shamanic understanding. Grandmother's spider web of light.
Oh,
Okay.
No idea.
I can't remember my granny talking about black holes and neutron stars and things like that. But obviously, she was keeping it close to her chest.
Listen. I come from a very educated family. I was chatting with my grandmother about the Hubble constant before anybody else had ever heard of it. So there we are. So
Gosh.
yeah. Okay, number 4, arriving instantly. This answers the question how we can actually travel across the universe and arrive at our destination instantly. I bet you were wanting to hear this one.
Yeah, come on. I'm on the edge of my seat.
Maybe we need to travel at the speed of dark with no light, no need to see the distance traveled, so arrive instantly.
Brilliant.
speed of dark.
Absolutely brilliant.
That title promised so much,
I know.
and it lied.
And it delivered so little. I
So
know.
basically, if you close your eyes, then you can instantly go somewhere.
Yeah,
Right.
I know. Yeah.
It's called a dream, Gaz. That's a dream.
Well, yeah, but hang on a minute. Have we measured the speed of dark?
Yeah.
Just don't go there.
Well, because remember, when you turn off a light,
yeah,
the light doesn't just disappear. The actual light bulb sucks all the light up, and then the dark comes in. So how fast does that dark come in?
Is that what it is?
but there's lots of dark energy there.
Yes. All right.
And, does the light go out in the fridge or not?
Well, we try to rationalise these.
Yeah. Oliver Massey, according to these saps here, you may be onto something. So there we are. Okay, number 3. Try telling that to the Mercury 7. Somebody's redesigned the NASA emblem. And they think that everything NASA says is fake, but the way that they've redesigned it might prove slightly controversial.
What?
Yeah. As I said, try telling that to the Mercury 7. You wouldn't have lasted 10 seconds.
I just want to say Jupiter doesn't have that color blue. It's much more.
Right.
Yeah. And it's a red spot in the middle, not gay.
Yeah. So this guy thinks that because NASA is gay, everything they say is fake. which does reveal some rather deep-seated prejudices, in my opinion. But interesting reinterpretation of the NASA emblem there.
Yes, the meatball.
Yeah. Number 2, somebody talking about images from Perseverance on Mars. That's in Atlantis.
What?
That's in
What?
Atlantis.
Yeah, apparently it's all filmed in Atlantis, not filmed on Mars at all. It's all filmed in Atlantis.
Well, I must have missed the memo where they discovered Atlantis. We've been looking for a long time.
Yeah,
Oh, yeah.
yeah, absolutely. So there we are. And finally, number 1 on the hit parade of insanity this week. Straight in at number 1 this week, we have the sun in peril. Now, here's the image that the guy is referring to, which is yet again the comet. Quiet object dances with Neptune's pull. Distant solar system body remains unidentified. No, it doesn't remain unidentified. It's a comet, for goodness sake. But one person was rather concerned about the sun in all of this. What if it takes out the sun?
Oh man, I hate when that happens.
Yeah, definitely.
We're all doomed.
Yeah, we're all doomed. So somebody concerned about the comet taking the sun out. So
Well, we
there
can
we are.
answer that, you know. And
Yeah.
you have 8 minutes to pray. That's it.
Yeah, that's it.
Mm.
That's it.
Mm.
So there you have it. This week's Einstein of the Week. It's to be hoped that we have another bonus week next week, but one never knows the insanities that lurk in the dark underbrush of the future weeks to come. So that was Einstein of the Week, and I hope you enjoyed that, viewers.
Yeah. Well
So
done.
there we are. Time's up, says Derek.
Mine's right.
Oh, Derek,
Well done, Derek.
by my clock, I'm about 30 seconds late. Give me a break. So there we are.
Write a term paper for Sandra.
Yeah. So there we are.
Yeah.
So thank you very much for being with us this evening. Under orders from Derek, we're going to say goodbye now. So we would like to thank you so much for watching, as ever. Don't forget, we've got Mars Month coming up in September. I've just decided we're doing it in April now. That's it. It's going to happen.
April is the new September.
Yeah. So in September, correcting myself, we're going to be doing Mars Month. Don't forget, if you join our Patreon, you can help not only to support the channel financially, but you get lots of goodies. You get all the downloads, you get prezzies, and you get lots of other stuff as well. So do go to patreon.com/Space Oddities and become a member. We're trying to build a little community there. We got all sorts of chats there. You can talk to us. You can talk to each other. Why not give it a go? You can always cancel if you don't like it. I mean, just give it a go, please. So there we
First
are.
10 members get a date with Michael. So, don't be late.
The first prize is a date with Michael. Second prize, 2 dates with Michael. So
I haven't got time.
Oh.
oh no, in your busy social calendar, if one wants to euphemistically put it like that. Anyway, and don't forget the website, https://spaceoddities.space, and go and have a look around there as well. See, we give you everything here at Space Oddities.
Yes.
We'll be back next week. Next week
We'll be back.
is another week. So we'll see you next week. Not quite sure what we've got for you next week. But anyway, so we love it that you're here with us. We love sharing this stuff with you. You're a great bunch of guys, and we wouldn't have it any other way. So 2 hours it is, guys. Derek, don't worry. Next week, I'll have a little clock here. Don't worry.
Yeah, get the egg timer out.
I'll put a little old mechanical clock in front of me that my grandmother bequeathed to me after she died. Well, she didn't bequeath it to me after she died. She bequeathed it to me before she died, obviously. But anyway, we'll see you next week. I'm rambling. I must stop. So have a great week. Take care of each other, and we'll see you next week.